Are you just getting started with Swift testing? In this series, I'm going to show you how to get started with Swift testing coming from XCTest. So I've got this simple XCTest that we're going to try and re-implement in Swift testing. So let's go ahead and create a new project. So we'll go ahead, create a brand new project. We're going to do an iOS app, and we're going to call this rounding app. We're going to use Swift UI, and then we're going to do Swift testing with XCTest UI tests. So that's the only option that we can choose. So that means it's going to give us a bunch of tests, and I'm going to put it right here. And we're going to work our way towards getting this to be operational. So right off the gate, we're going to have a Swift UI app, and we're going to have some sample tests that don't really do anything. But if we were to do a Command U to run the unit test, we're going to notice that it's going to do a lot of things. So right now it is actually defaulting to my iPhone, which I don't understand the error message that it's giving me. I actually want to run this on my simulator. So let's try that one more time. Command U to run the unit tests. And what we're going to see is that it is launching tests on 3 different simulators, which is probably not what you were expecting, but this is the default behavior once you are creating a brand new project and if you enable the test. If you add the test manually, you don't have this issue. And so this can be a little bit too much, and we're going to learn how to control that, and then we'll get into migrating some of those tests over into the Swift testing. So up first, we're running way too many tests, and typically I would delete these. It's adding things that I didn't want, but we can control that with the scheme. So we can control the scheme with the Command Shift comma. That will bring up this menu as well. And then what we're going to need is a testing plan. Now, every time I've done this with Xcode 16, it's crashed on me. We'll see if this crashes or not. But if you click this little arrow button on the test and debug for the test plans, we need to go ahead and create one of these so that we can control which tests are running. I keep seeing this error, so we'll save it, and it crashes. Maybe I'm not supposed to hit save there. Let's open that up again, reopen. Did it not open the one I wanted? Okay. No testing plan. Let's see if we can. I think if I do it again, Command Shift comma. Oh, no scheme. Okay, so this is a separate issue. So if you run into this issue, this happens all the time when I try to do this. You need to go to Manage Schemes, and then there is a button at the very top that says Auto Create Schemes right now. For whatever reason, we've corrupted this Xcode project, and you need to click on Auto Create Scheme now, and then hit Close, and then we should have a scheme. We're going to select our iPhone. If we run those unit tests and UI tests, we will see something happen. I'm going to go back into Edit Scheme. So we're going to try this again, and I'm going to click on this. Let's say don't save. And it doesn't crash. Great. We've got a bunch of simulators here. There's a lot going on. Looks like I just have 2 simulators right now. Oh, here comes a third one. So there's a lot of tests happening. This can be too much when you're just getting started, and if you want to cut them out, that's where the test plan is going to allow you to limit the number of tests that are running. And then if you don't want the clones to appear, like right now, it's enabled for parallelization, and that's great if you want to run the test quickly. If if you want the previous behavior, now it's going to let me save it. Let's save the test plan. And now if we go ahead and run the unit test, it should just give us one simulator rather than having a clone 1 and clone 2. We're going to have a fourth simulator. So I've got 4 simulators right now. And it just ran those tests. So I'm just going to get rid of the clones, just closing them with Command W, and we're left with just this. I just want a simple testing environment. I don't need all the parallelization because we're only going to be writing 1 or 2 tests. Okay, so that's a starting point. You can get rid of these. The other thing that I tend to do is for like these, if I don't want to actually use them, I will just delete them and get rid of them because I might not want the launch tests or I might not want the app tests. So those are 2 other options that you have here. But if you want a starting point, it gives you a starting point. All right. So now back to, and that's those, to be clear, are not with Swift testing. So this is using XCTest and this is using XCTest. If you want to do UI testing, you have to use XCTest. It's not supported with Swift testing. And it's unclear to me if it will be, but I haven't been reading too deeply into that. So I really like a lot of aspects of the Swift testing, and we're going to try and dive into that. And I had some notes here, but the one issue that I ran into, if I can find my app, is that I want to test accuracy of floating point numbers. And so I have to do this for some math calculations, and we're going to just rewrite these tests over in Swift UI. So I'm just going to copy this. Or actually, we can probably just keep them both open at the same time and just have them side by side so you can sort of see Swift testing versus Swift UI. So we've got XCTest versus Swift testing. So I've got the unit test that we want to test, and then we got to find the chunk of code that is actually going to be under test. So let's just copy this into this project, and I'll just paste it here. So this is my rounding behavior. Pretty sure I'm using it. Okay, so we've got a little comment here. This allows us to round to a certain number of places with a rounding behavior. And I've got an enum that can control that. So I was just testing one of these functions to do this math calculation. And we want to retest that in Swift testing. So we've got basically an extension on double. In this case, I would do something like double plus as the name. And you could put this somewhere in your application. So that's the chunk of code that we want to test. We're going to jump on over to our unit test. And why don't we open up 2 files? We'll have the rounding behavior so that we can sort of see the implementation down below. And then we'll start writing our test up above. Let's play around with some window management here. All right, so the new thing that you're going to be using in Swift testing is going to be the expect syntax. That's opposed to the XCT assert equal, where you would have to put both things together. And this one's kind of interesting. I think I have some other notes that I'll cover in more depth. But let's focus on the accuracy here, and we'll get into some of the other ways that you can write these tests next. So we've got these different values that I want to test, and how do I want to do this? Let's write it the same exact way. So we're going to have our starting variable. So let a equal, I don't even need to give it a type, I don't think. This should just default to double. So 305.39483. Okay, so we've got some values here. And then all we need to do is use this new expect macro, and we can verify something is going to be what we expect. So we do that by saying something like this. So if I want to test the 3 decimal places with this number, I'm going to say this value that I'm expecting, and I'm on the fence how I want to do this. Let's write it this way. A rounded to, and then rounded to places is the one I wanted. And I want 3 decimal places. And then I'm going to have the value that I expect. And that's going to be 305.395. Okay, we go ahead and run our unit test. And writing this slightly wrong because in Swift testing, we write it with the double equal signs, and it's supposed to just figure it out. And we can sort of see if this works. Now, if there's any kind of like fuzziness with the rounding behavior, you can't verify that this is always going to work correctly. And so that's where you can run into potential problems. I think for all of these examples, this might actually work fine. So if I want to test B rounding, this becomes more problematic when we're doing floating point math calculations. So we go ahead and run these. Probably going to work. Floating point math calculations are really problematic when you want to verify that things are working properly, because when you're doing calculations, you can get some drift in the floating point ish, and it can create some issues. So for anything where we're doing math calculations, we typically want to have some kind of tolerance. And that's previously what I had, but I don't have that functionality right now with this. And so the way this rounding is working, I think it's going to be pretty predictable. If I was actually doing some math calculations, let's try another one. So if I do like 127 divided by 53. And I want to compare this to, let's make this a double. And let's call this that result. You want to be careful about this. So let's say that the result is going to be 127 divided by 53. It's going to be doing some macro like expansion stuff. So we really don't want to do calculations in this expect condition. And we're going to compare this to, and so I did 127 divided by 53. Let's say I wanted to say that this was at least, let's copy this value. So that's going to give us some number. If I wanted to say that this was approximately equal to something like this, and we run our unit test, we're going to get a failure. So here it's going to tell us that this has failed. Now this is where you can run into random tests failing at random times because of different conditions and calculations. And so to avoid that, we can't leverage, there is no API that I'm aware of. Expect. There's no API that's going to give us this accuracy term that we had before. If we Google it, oops. Well, if you want to get this code, you can download it here. Let's open up a new. So this was the old method. And we want this in Swift testing. If we just search for this. So if we search for this, there is some tracking. This got merged. So does that mean it's available now? No. Okay, so drop currently. So the recommendation was still numerics, I think. And so this is recommending that we should use is approximately equal, which is what I'm going to show you how to do. So let's go ahead and do that. In order to get this to work, we need to add a package. So we're going to go up to File, and then we're going to do Add Package Dependencies. And we're going to type in Swift numerics, and then we're going to add this package. So we can do up to the next major version to the rounding app, and we just say add package. That's going to go ahead and fetch it so that we can leverage this logic. And we'll wait for that and say add package. So now we have the Swift numerics. And then after we do that, let's close this out. This is going to give us access to some stuff in our tests. So we are going to import numerics. And then what we can do is for all of our tests, we can expect and leverage this value. So we would rewrite this expression like expect and then result, and then there should be dot is this is what we I think wants, but it's giving me some weird stuff here. So here I would say this is approximately equal to some results, 236,226. And let's give it a tolerance of 0.01. We could even take away some of this. And then, okay, so that's what's going on. It doesn't see the symbol yet. So we need to go over here. And I think that's what I had done in my demo project, but it's been a while. So let's just double check this. Yes. So importing the package is the first step, but the second step is actually adding the framework to our unit tests. Or do we need to add it to the main project? We're only using this in our unit test to verify things are working. So we're just going to pull in the numerics library into the library and framework section, or the frameworks and library section. So to get to this point, you're going to click on the project. You're going to click on the targets. You're going to go to the unit test target. And in here, we are just adding the numerics framework. Okay. So if we do that, now we should be able to build. It shouldn't be giving us an error about that situation. And then I think it was pulling in the wrong symbol. So let's just go ahead and rewrite this. Expect result dot is approximately equal to, and then it was absolute tolerance that I think I used. Is that what they're recommending? Is approximately equal. So we did 2.396, then we could give it 0.01. And if we go ahead and run this, this one is an incorrect API. Okay. So that is how we can add Swift numerics so that we can then test and expect this to pass. If we start playing around with the tolerance here, so let's say I want a smaller tolerance, so a smaller value. So let's say this, we incorrectly round it, but let's see. This should fail. So here we've made a smaller tolerance. And so this would just be helpful when you're like pretty close. If we make this a little bit less, what we're going to see is that it should pass now. But as we make it finer and finer, the amount of deviation has to be a lot smaller. So typically in my test, and it depends on how many calculations you're doing, but if it's just like a single pass of calculations, I think you can get away with doing like 0.001 or one extra zero here. If there's multiple layers of calculations happening, you're going to have more drift and more issues with the numbers being further and further apart. So that's where there's different APIs all related to this. And if we jump to definition, you can learn more about this API from the Swift numerics. I don't know if they have a link to it. Let's go over here and we can learn how to use the Swift numerics. So that's a little bit of getting started with the unit testing in Swift testing. So here, this is actually expecting us to round a little bit finer. So to get this to pass, it's going to require more decimal places that are a little bit closer. So that is Swift testing, getting started, controlling it with your test plan. When you do that, you will get a test plan up at the top that allows you to configure which tests are running. Remember, we changed the parallelization to make it so that we only got one simulator when we're running our tests. You might like that. If you want your test to run as fast as possible because you've got a lot, then it makes sense to parallelize them. But most of the time, I'm just trying to isolate which unit tests I'm running. So I'm running one or two tests or one file of tests. And you can use these checkboxes to do that. All right, so hopefully this was useful. Hopefully you learned something about testing with Swift testing and the numerics library for doing any kind of floating point calculations where you need to say, this is approximately equal to 0 or approximately equal to something, because you can have rounding issues with those values. Thanks for watching. And if you do want to get access to the code, I'm probably going to throw it in this, so you can jump on over down to the link below to get access to this sample code so that you can play around with the Swift numerics and get started with that. So I'll have a link down below. Just click that and you can get access to this sample code. Thanks for watching, and I'll see you in the next video, which I'm going to talk more about unit tests. I think we're going to flesh this out a little bit more. So there's going to be a part 2 on this one, just to keep everything together. I'll see you in the next one.